the fourth tutorial on OpenCV. So we're going to Google OpenCV, and we're going to go down to tutorials, and we're going to go to the core functionality, the basic building blocks of the library, core module, and we're going to go down to operations with images. In tutorial 3, we went over input and output. So we're going to go down to basic operations with images, accessing pixel intensity values, and we're going to click on Python. In order to get pixel intensity values, you have to know the type of an image and the number of channels. Here's an example for a single channel grayscale image. Type 8UC1 and pixel coordinates X and Y. Intensity equals image Y, X. C++ version only. Intensity.val 0 contains a value from 0 to 255. There's some things in OpenCV that you have to do in C++. Note that the ordering of X and Y, generally you have X and then Y, but in this case, they have Y first and then X. Since in OpenCV images are represented by the same structure as matrices, we use the same convention for both cases. The zero base row index or Y coordinate goes first, and the zero base column index or X coordinate follows it. C++ code. So we're going to go down to the Python code. For Python, blue equals image Y, X, 0, green equals image Y, X, 1, red equals image Y, X, 2. That's a good tutorial on operations with images. In the last tutorial, we went through input, output. In this fourth tutorial, we went through basic operations with images, accessing pixel intensity values. Top, I think we can control home. Yeah, if you hit Control Home on your keyboard, it'll go to the top of the screen. So now we're going to hit the back button. And the next, we're going through the core functionality, core module. And we just did operations with images. Now we're going to do adding blending to images using OpenCV. In adding blending to images using OpenCV, we'll learn how to blend two images. In this tutorial, you will learn what is linear blending and why it is useful, how to add two images using add weighted theory. Note the explanation below belongs to the book Computer Vision Algorithms and Application by Richard. From our previous tutorial, we already know a bit of pixel operators. An interesting dyadic two-input operator is the linear blend operator. So we have the function g of x equals 1 minus alpha times f naught of x plus alpha f sub 1 of x. So by varying alpha from 0 approaches 1, so it goes from 0 to 1. This operator can be used to perform a temporal cross dissolve between two images or videos as seen in the slideshow and film production. Cool, source code. So we're going to click on Python, and here's the source code for Python. In the next tutorial, we'll run this in Python. For now, let's go through the explanation. Since we're going to perform the blend for this equation, we need two source images, f naught of x and f sub 1 of x. So we load them in the usual way. src1 equals cv.imread, cv.samples.find file, Linux logo.jpg. We'll probably just dump the file right into Python to make it easier, like we did with starry_night.jpg. src2 equals cv.imread, cv.samples.find file, windows logo.jpg. We're going to cut that part of the code out in the second parenthesis when we do our code in PyCharm. We use the following images: Linux logo.jpg and Windows.logo.jpg. So we're going to store these two to our desktop. I'm going to open it, right click, open a new tab. So here is the Linux logo, and we're going to right click, save image as Linux logo, and we're going to save to the desktop. So we're going to hit save. Now I'm going to close that tab. Now here's the Windows logo. We're going to right click, open, link a new tab, and we're going to same image as Windows logo, and we're going to save that to the desktop. And we're going to close that tab. So now we have those two on our saved to our desktop. Warning: since we added src1 and src2, they both have to be the same size, width and height and type. So they both have to be type JPEG, JPG, JPG, and then they also have to be, same width, same height. Now we need to generate the g of x image. For this, the function add weighted comes handy. Beta equals 1 minus alpha, dst equals cv dot add weighted src, comma alpha, comma src2, comma beta, comma 0.0. Since added weight produces dst equals alpha dot, times src1 plus beta times src2 plus gamma. In this case, gamma is the argument 0.0 in the code above, 0.0. There we go. Create windows shows the images and waits for the user to end the program. cv.im showed dst, comma dst, cv.wait key 0. So here will be the result of the linear blend. So it blended the Linux logo.jpg and the Windows logo.jpg. And in the next tutorial, we'll show you the blend in PyCharm. So if you hit Control Home, it'll get us to the top of the page, and we'll scroll down. And the source code in Python is, we'll go to the link, download the source code from here, and we're going to click on that for the next tutorial, but that will be tutorial 5. Thank you for watching. That's all for today, folks. If you liked the video, please give it a thumbs up, and if you have any questions or comments, please make them below the video. Thank you.